Hello and welcome to today's video. We're going to be talking about rational numbers and what a rational number is, how to prove that a number is rational, and we'll be looking at different examples of different subsets of rational numbers. So I'm so glad that you are joining us today. It's very important that you use this time wisely, so please make sure that you are taking notes as we go through. I'm going to go over the definition and some different facts about rational numbers at the beginning. It will be very helpful to you to copy that down in your math notebook so that you have it to refer to and look back at when you're studying and trying these problems on your own, and make sure to copy down some example problems also. You can even pause the video and rewind if I go too fast to get caught back up. I'm so glad that you are joining us today, and let's go ahead and take some notes. In this lesson, we're going to be talking about rational numbers. So it's important to have the definition of rational numbers written down. These are numbers that can be written in the form n over d, where n and d are integers, so they can be positive or negative whole numbers. And d is non-zero, so the bottom can't be zero. So basically, they can be written in fraction form. So this could be 3/7, -2/5, or 4, because 4 you can write as a fraction by putting 1 over it. So if a number is a fraction, you know it's a rational number. You can tell that a number is rational looking at the decimal also. If the decimal is repeating or terminating, that means it's a rational number. Terminating means that it ends. It has an end. It doesn't keep going forever and ever. There's a definite end spot. To prove that a number is rational, sometimes you'll have to take the decimal form and write it in fraction form, because if you can show that that number can be written as a fraction, then you know that it's a rational number. So to convert a decimal to a fraction, you're first going to use the place value of the last digit to the right of the decimal point in the denominator. So here, to the right of the decimal, the last digit is a 5, and that's in the hundredths place value column. So that means I'm going to put this decimal over 100. So that means because that 5 is in the hundredths column, I'm going to have 100 as my denominator. Then you remove the decimal point and make that number the numerator. So I get rid of the decimal point and put the whole number on top, and then I reduce it if necessary to lowest terms. Rational numbers can also be broken down into smaller groups of other numbers that are more specific. And these are vocabulary words that you've probably heard in the past. And so just as a reminder, if you're talking about natural numbers, which are also called counting numbers, so 1, 2, 3, 4, 5, those are natural numbers. Those are also rational numbers. Whole numbers, which are the natural numbers plus 0, are also rational numbers. And integers, which are whole numbers and their opposites, so the whole numbers and the negatives, so like -8, -3, plus 0, 4, 10, and 9. Those are all integers. Those are also considered rational numbers. And then when you add in the decimals and the fractions, those are just rational numbers and no other specific ones. So in this section, there's going to be some vocabulary questions. And here it wants to know, is a terminating decimal, is that considered always, sometimes, or never a rational number? So if you have a decimal that ends, that terminates, that's always going to be a rational number, making your final answer B. This question here has to do with those notes that we took on the subsets 2 slides back. It says every integer is a blank number. So integers are a more specific type of rational numbers. So that's going to make C my answer. This question here wants us to prove that this decimal is a rational number by putting it in fraction form. Since a number being in fraction form is the true definition of a rational number. That's why you have to do this. So remember, you're going to look at the place value of the last number to the right of the decimal. And so that here is a 2, and that 2 is in the thousandths place value. So since that 2 is in the thousandths place value, I'm going to put 1,000 as my denominator. Then my second step is to remove the decimal and put this entire number in the numerator. So that's going to be a 1,752 in the numerator. So now I've been able to take that decimal and write it as a fraction. So I've proved that it's a rational number. As I look at my answers, they didn't simplify it any more than that, because whether this fraction is simplified or not, it's still a fraction. It still proves it's a rational number. So that's going to make my final answer A. This problem is the same idea as the last one. I have to prove that 1 and 27/100 is a rational number by placing it in fraction form. So the first thing I'm going to do is look at that last number after the decimal. So here it's a 7, and that 7 is in the hundredths column for place value. So that means in my denominator, I'm going to write 100. Then my next step is to take this entire decimal, but remove the decimal and write the numbers in the numerator. So I'm going to write 127 in the numerator. And because I was able to take this decimal and write it as a fraction, I've proved that it's a rational number. I don't need to reduce it. And that's going to make my final answer B. This question gives us 4 different sets of numbers and wants to know which is the only set that contains only rational numbers. So remember, rational numbers are numbers that can be written as a fraction. And if you're looking at the decimal form, the decimal is either repeating or ends, terminates. So in letter A here, I'm looking 1,629. That's a number that ends. That's a terminating decimal. It doesn't have a decimal point because there's no numbers after the decimal. But a whole number is an example of a rational number. This number is in fraction form, so I know for sure that's a rational number. Here is another decimal, and this decimal ends, so I know that's for sure a rational number. And this is the square root of 5. I don't know if I can write that as a fraction or what that decimal looks like. So this is when you're going to pull out your calculator and take the square root of 5 and see what that decimal looks like. When you put it in the calculator, for the square root of 5 should equal this big long decimal. And it looks like on the calculator that the decimal ends. However, the calculator just only has so much space on the screen. This decimal can keep going on and on and on forever. If you were to find another calculator that had a bigger screen that could hold more numbers, you would see even more numbers after this fraction. So because it fills the whole screen, that tells us that that decimal does not end. It keeps going on and on and on. So since it doesn't end, that means that square root of 5 here is not a rational number, so it can't be A. In B, our first number here is the square root of 3. Well, I don't know what that looks like as a decimal, and I don't know what that looks like as a fraction. So I'm going to use the calculator again to calculate what is the square root of 3. And when you place that into the calculator, you're going to get another big long decimal that fills the entire screen. And so that tells us that the decimal is not ending, it's non-terminating. So that means that this square root of 3 is not a rational number. So it can't be B either because of the square root of 3. Now C, my first number there is a whole number. That's a rational number. And then I have this letter pi. Pi, by definition, is a decimal that never ends. So pi, if you were to look it up, would be 3.14159265383 979, and that decimal would just keep on going. You can Google pi, the decimal, and you can get lines and lines of numbers. It's never going to end. So C isn't going to be our answer because pi is not a rational number. So hopefully D is all rational numbers. So our first number here is a whole number. That's good. Our second number is a fraction. That's definitely a rational number. Our third number is a decimal that ends. So it's definitely a rational number. And I don't know about the square root of 144. So I'm going to use my calculator to find out what the square root of 144 equals. And when you do that, you should find that the answer is 12. 12 is a whole number. It ends. So that means that the square root of 144 is also a rational number, and that means D is going to be my final answer. The second question is also looking for which of the following sets is all rational numbers. And so I just need to go through and think about what I know. Rational numbers are always fractions, and rational numbers in decimal form are always ending or repeating. So in letter A here, I have a decimal, and that decimal ends. There's only one number after the decimal point. So that is a rational number, so that one is good. And then 37 is a whole number. That's a number that ends. So 37 is a rational number. 12.48, that's a decimal that ends. It only has two numbers after the decimal, so that one's good to go. And I don't know about the square root of 25. Anytime you have those square roots, you have to use the calculator to help you. So here, if you take the square root of 25, you're going to get 5. 5 is a number that ends. So that means that the square root of 25 is also a rational number, because when you simplify it, it just becomes 5. So that means A is going to be your final answer. And it's always good to look at your other answers here to make sure that you didn't make a silly mistake. So in B, anytime I see that pi, I know that symbol pi is not a rational number, because like we talked about on the last slide, it's a decimal that doesn't end by definition. So because of pi, B can't be your answer. C, I have a square root there that I need to check. That square root of 47, when you check that in the calculator, is a decimal that doesn't end. It keeps on going and going and going. And it fills up that entire calculator screen, and it could keep going, filling multiple calculator screens. So it can't be C. And then D also has a square root that you need to check. And when you put the square root of 13 into your calculator, you get 3.60555127546, and it just keeps on going again forever and ever. It could fill up multiple calculator screens. It just ran out of room. So because of the square root of 13, that decimal not ending, our answer can't be D either. So thank you for joining us today, and I hope you learned something new.